Let's start again. So we're going to have a look at distributive law and how we distribute multiplication across certain different numbers and how that actually looks mathematically. So if I said to you guys, what is 3 times 4? Hopefully you think of 12. A way we can show that is through the area model. And I'm going to show you guys how to do that basically today, but it's an array is another thing it's called. But really all we're doing is we're actually, when you multiply 2 numbers together, you could say that would find the area of it as well, because you're sort of really counting blocks if you want to go quite back a fair bit in your mathematical education. But look, there's 12 blocks. That's your answer. That's 12. So we sort of used the area model previously before. If I said to you, what is 5 times 12? What does that equal? You might just know it off the top of your head as 60. Again, I could show this as the area model, which is 5 by 12. And you'll get an area of that as 60. Okay, now if we get a little bit more technical, what if I said to you, what is 12 by 15? Okay, so some people might be thinking a little bit more about what is 12 by 15. So if you think about that in your head, not many people know 12 by 15 off the top of their head. Some people might go, oh, 15 tens is 150 plus 2 15s is 30. That makes it 180. So you can kind of get there. Some people might go 12 tens is 120. 12 fives is 60. Add those two together, that's 180. Let's look at those 2 ways that we can break that down. So in your head, that's what you might have done. When we're doing that, 12 by 15, we can actually show it as an array. Now, when we're doing 12 by 15, let's just break it down with, let's do the 10 by 15 and then the 2 by 15 and add it together. So this total length here is 12, right? Now, remember, if you do 2 multiplications, just like 3 by 4, the inside area is your answer when you're doing multiplication. And this is 15. Now, this is really key about understanding the distributive law. I'm going to break this down into a 10 and a 2. So really what we're going to do, instead of going 12 by 15, you're like, ugh, that's a hard one. You might have gone 10 by 15 is 150. Plus 15 by 2 is 30. So you go, oh, that's 150 plus 30, which equals 180. What we've done and how we actually do this and write this mathematically, well, what we've done is actually we've broken down the 12 by 15. That's what we've done. What we've actually done is we've broken down this 12 into a 10 plus 2, right? Because that's what we did. It's 10 plus 2. That's what this length is, 10 plus 2. We've just broken it down, and that's still 12 by 15. And then what you did is you went, well, 10 by 15 gives me 150. How we do this is called the distributive law. So I can actually rewrite this now as well. It's 15 lots of 10 plus 2. It's 15 lots of 10 plus 15 lots of 2. That's what we're saying here. 15 lots of 10 when you did your first multiplication gave you 150. Plus you did 2 lots of 15. You did 2 lots of 15. So why we call this the distributive law is because you're distributing this multiplication of 15 over the 10 and also over the 2. And this is pretty much all you're doing. You're just doing the multiplication of those. And that's how we do it with the array model. Alternatively, you might have done a different array model. You might have gone, oh, okay, instead of breaking down the 12, I'm going to break down the 15. So you might have gone with 12. And instead of doing it by 15, you might have gone by 12 by 10 first and then by 5. If you went 12 by 10, you're going to get 120. If you went 12 by 5, you're going to get 60. So what you're actually doing here is you're going 12 by 15, and we're actually changing the 15. We're doing a multiplication of the 10 first, and then we're going to add the multiplication of the 5. So mathematically, we write like this, and this is called the distributive law that I'm doing now. I'm doing this. I'm distributing this multiplication of 12 over these terms. So that's going to be 120 plus 60, which equals 180. Notice these will both equal the same number. They both equal 180. me ask you another question. This is actually what we do when we do the multiplication. Let's say if we said, what's 243 times 24? 20, let's go with 20. Yeah, let's go 4. Why not? Well, you're going to be like, oh, I don't really know what that is. You might do this. You'll probably go, to your old default of 243. A lot of people do this by 24, and there's nothing wrong with that. 4 threes is 12, carry the 1. 4 times 4 is 16, makes it 7, carry the 1. 4 times 2 is 8, plus the 1 is 9. And then you add on. We're going to add a 0 because we're multiplying in the tens column. 2 by 3 is 6, 2 by 4 is 8, 2 by 2 is 4. Then we add these together because this is an algorithm that you've been shown. And that's going to be 3, carry the 1, that's going to be 8, carry the 1, and that's 5. Okay, let's see what we actually did here as an array model. 243 by 24. Well, we can do the same thing. And what you actually did is you did do an array model. So I'm going to break the 20 into 24 into 20 and 4. Because this overall length is 24, because when you multiply two things, it's the area. I'm going to break the 243 into 3, 40, and this isn't really to proportion, so I do apologize. And then 200. I mean, this 200 should be going on a lot longer. Technically, with the area model, it should be the same length, but hopefully you get the idea of what I'm doing. So the first thing we did in the algorithm is we went, well, 4 by 3. Here's 4 by 3. That's going to give you 12. So you put down the 2 and carried the 1 up here in the 12 column. Then you went 4 by 40. 4 by 40 is, 4 by 4 is 16. That's 1600. So you went 1, 6. We've got the 0. So 1 and 6 made a 7, and you carried the 1 there. Then we went 4 by 200. 4 by 200 is 800. So that was 800. That's why it's 8 in the 800 columns, plus the one that we carried on before. So what you actually did is, if you notice we did the 4, if you add all these up, that's actually going to be 972, sorry. Notice this is the same number. So really all you're doing is you're just 4 by the 3, 4 by the 4, 4 by the 2. It's 4 by 3, 4 by 40, 4 by 20. Then you went with the 2. Why you add a 0 is because you're actually going 20 by 30, which is 60. And that's why you're actually placing the 6 here, because it's actually 20 by 30, or 2 tens by 3 gives you 60. Then the next thing we did is 20 by 40, which gives you 800. So we put 800 in the 800 columns. And then the next thing I went was 20 by 200, which gives us 4,000. And that's why we put a 4 in the thousands column, which gives you 4,860. And then why we add them together is because it's giving us the total area, which is going to give us, what are we looking at? 2, 3, 8. Yep, carry the 1. 5,832. So you've actually been using the area model the whole time with this algorithm. It's exactly the same thing. And you've been using the distributive law. So really what we did here is, instead of going 234 times 24, when you do the algorithm, you're really going, well, 200 plus 40 plus 3 multiplied by 20 plus 4. I mean, that's what we did. So what we did the first time is we went, well, 4 by 3 gives you 12. 4 by 40 gives me 160. 4 by 20 gives me 80. Then you did your 20s. 20 by 3 gives me 60. 20 by 40 gives me 800. 20 by 200 gives me 4,000. And that's how you do it when they're written with brackets. You need to multiply every term in this one with everyone in that one. And then every one of this one with everyone in that one. You don't obviously multiply in between the brackets, but it's just between them. And you distribute them out. So really, if we wanted to look at that, the first thing you would do would be, 2, and that's where you get your numbers from. 4 by 3 is 12, 4 by 40, and you can write those all out and you'll get there. That's where we're going with the distributive law. That's how we're going to expand brackets. Now, the only thing different that we're going to do is we're going to introduce algebra to this. So, for example, I might have 4 multiplied by x plus 3. So 4 by x. So what am I doing here? Well, this is an array model. 4 multiplied by, we've got x, and then we've got plus 3. Well, 4 multiplied by x would just give you 4x. 4 multiplied by 3 would give you 12. And these are added together because it's positive 12. So that's going to give you 4x plus 12. What a lot of teachers will show in the shortcut method is you just multiply this one. That gives you 4x. 3 times 12 will give you positive 12. 3 times 4, 4 times 3 will give you positive 12. And that's how you can get there. Let's try another one. 5. Let's go with 3 plus a. I'm going to distribute the 5 times 3. That will give me 15. 5 times a will give me 5a. 15 plus 5a. So what happens if we've got some more numbers in there? Well, if I've got 3, 5 multiplied by 3 plus 4a. 5, 3 plus 4a's. That'll give you 15. You got 4a's along here. Well, you're just going to end up with 5 times 4a. You'll end up with 20a's in here in total. So that will give you 15. 5 times 4a, 20a plus 20a. If it was slightly different, minus 4a, you're still going to get your 15, except when this is negative, that's going to make that negative 20a. If you've got a negative number out the front, negative 3 lots of 5. And we've got plus 2a here. That's going to give me negative 15. Negative 3 times 2a will give me negative 6a. So the answer for that is negative 15 minus 6a. So this is called expanding, okay? This is called expanding. We're expanding that because it gets bigger, right? We're expanding the brackets. So this is what we call expanding. So another term it might be called is expanding this. If I said, hey, factorize that, that means we're taking out common factors. The most common factor in this would be negative 3. And then we actually put it back into this term. So going from here to here is called, that is equal to this one, negative 15 minus 6a. This is probably the best example to choose. Going from this way to this direction is called expanding. And going from here to here is called factorizing. Why do we call it factorizing going back? Because these are your factors. Your factors are on the side. Like if I said to you guys, what's the factors of 12? If you've got an area of 12, your factors could be, it could be 3 by 4, right? So I can write 3 as 3 by 4. They're my factors. Or I could write it as 1 by 6, 1 by 12, sorry, 1 by 12. Your factors is 12. They're on the outside, 1 by 12, and it gives you no remainders. So it could also be 2 by 6, which gives you the area, right? So that's why we call it factorizing when we take it back the other way, because we're looking at what two things are multiplied to give you the area. So when we're expanding, notice if you've got negative numbers, the same thing can apply. If you've got like negative 4 minus, let's go with 5b. Here, negative 4 times, negative 3 times negative 4, that would give you positive 12. Negative 3 times negative 5b, that would give you negative, that would give you positive, I should say, 15b. So the answer for that would be 12 plus 15b. So just be careful with your positives and negatives. Another thing you can do sometimes you can have a variable on the outside. So you might have something like this, 2x, 5 plus 2a. If I expanded this, 2x multiplied by 5, give me 10x. 2x, that was that, 2x multiplied by 2a. That's going to give me 4xa. So the answer for that is 10x plus 4xa. Another thing you can have, slightly different. If I have something like this and I want to expand it, that's going to give me 10x still, because it's 2x by 5. Then you've got 2x. Now, when you go 2 by 2, that's going to give you 4, and x by x will give you an x squared. So that's going to make it x squared. So the answer for that would be, I'm going to write it with 4x squared, because that's the higher power, plus 10x. So even though you would actually have it as 10x plus 4x squared, we always write with the higher power first. That would be your first term that you would write there. So that's how we expand the brackets. So just be careful of positive and negative, and that's how we use it with an array model. It's something you have been using a lot, and we call it the distribution law, because you're distributing over, over the 4x will be distributed all over these numbers. Okay, let's make that a 6. Notice this is multiplied by everything, because that's got a multiplication there. We just don't write it. This 3x will be the last thing you do, because we still need to follow BIDMAS, PEDMAS, whatever you want to call it, BODMAS, BIDMAS laws. So the first thing you can do is the brackets. Can I simplify anything in here? No, I can't simplify anything in there. If you can collect like terms, you can. Sometimes you can collect like terms and do that. Then you're going to do inside the brackets, you can't do anything. Then you're going to do, is there any indices? No, there's not. I mean, there's one there, but there's none like out here. Then it's division and multiplication. Well, there's actually multiplication. So that's the first thing you're going to do. So that will turn it into 20 x to the power of 3, which is 20 x to the power of 3. This will be negative. Negative 6 times 4 will give you 24. X times x will give you x squared. Then I've got a positive number times a positive number. It's going to give me positive. That's going to give me 8x. Now I've expanded my brackets. I've distributed the 4x over all these, and I've still got this minus 3x. Now, can I collect any like terms? Yes, I can. These two are like. Voila, we're done. So all we're doing is just distributing this number to everything inside the brackets, and then we collect like terms. If there's an additional subtraction here or in front, don't worry about it. That is fine. Sometimes you can have things like this. Go with 4x. Distribute this. This is broken with a plus. So you're going to distribute this one and then this one separately. So that's going to give you 12x squared plus 8x. That's going to be positive 5 times 2x plus 10x, positive 5 times 1 plus 5. Now I can collect my like terms. These two are like 12x squared plus 18x plus 5. You'll notice there's something slightly different with this. I'm going to do the same example, except I'm going to change it to a negative 5. Now, you'll notice when I was expanding the other one, I was saying positive 5 times 2x, positive 5 times 1. Why? Watch this. 4x times 3x is 12x squared. 4x times 2 is 8x. Negative 5 times 2x, negative 10x. This is where most people stuff up. Negative 5 times 1 is negative 5. So sometimes people actually write this as a positive because they only think the negative carries for the first one. But you're distributing negative 5 over both of these. Negative 5 multiplied by 2x, negative 5 multiplied by 1. So again, I'm just going to change, and then you can collect like terms. 12x squared, that's going to be minus 2x minus 5. I'm going to do one more example. So if I've got 4x, 3x plus 2 minus 5 minus 2x minus 1. Let's go with plus 1. 4x times 3x is going to give me 12x squared. 4x plus 2 times 2 will give me plus 8x. Negative 5x times negative 2x. Negative 5, sorry, times negative 2x. Negative times negative will give you a positive. That's going to be plus 10x. Negative 5 times positive 1 will give me negative 5. Collect my like terms. And that is it there. Hope that helped.